So I'm Marcela, I'm from Brazil, and I started my PhD in February this year. So first I would like to thank my supervisors, Professor Ben White, Professor Phil Evans, Dr. Fiona Dempster, and Dr. Jacob Burson. So my project is a big project. There are many collaborators, and it's being funded by the Dung Beetle Ecosystem Engineers Project, the Scholarship for International Research Fees, and Research Priority Fund University Postgraduate Award. So for my project, I'll be looking at the economic value of ecosystem services provided by dung beetles to Australia. So before anything, I'll be doing an economic valuation to better understand the impacts of dung beetles on the Australian livestock industry, more specifically to farmers. So just so you know, the cost of cattle is really high, and the livestock sector can have an impact in the Australian economy. So this is the outline of my presentation. I will start with some background information. So ecosystem engineers, they are organisms that they modify the physical environment in a way that it can be beneficial to the ecological community. So examples are bee, earthworms, and dung beetles. So by modifying the environment, they can provide ecosystem services which are beneficial to people. And these benefits, they can be direct or indirect. So just for a better understanding, the bees, for example, they provide direct ecosystem services through pollination. So they increase fruit production, which is sold in the market, so it's a direct benefit. In the case of dung beetles, I'll be looking livestock productivity, and I'll be talking more about this later. There are also indirect benefits, which are more complex and difficult to measure. And examples are nutrient cycling and biological control. So the dung beetles, they are ecosystem engineers, and they can promote ecosystem services by incorporating and moving the dung into the soil. So what they do is they feed on the dung fluids and use the dung as food provision for their lives as well. So a bit of history. In the 1960s, Australia imported dung beetles to improve pasture viability and to control flying cattle as well. And we actually have native dung beetles, but they're not as efficient to bury dung as the imported ones. And CSR imported 50 species, but only 23 established in Australia. And since then, they have spread across many regions of the country. They have been redistributed, and new releases have been happening as well. So what we have evidence. So there are many studies conducted around the world that suggest that dung beetles, they contribute for recycle nutrients into the soil. They can increase seed burial, improve water infiltration when they do the tunnels underneath the soil, and all this can promote better plant growth as well. And not only that, but they also control pest flies and gastrointestinal parasites. So the biocontrol happens when the dung beetles are feeding, disturbing the dung, and competing for resources. So it damages the fly, egg, or larvae. So those are the things we know. There are a lot of things we don't know yet. So there is a lack of understanding on how dung beetle impacts livestock productivity. So we don't have evidence that they increase productivity, and that is what we are looking for. So no study have found ecosystem benefits provided by dung beetles to Australia in monetary terms. So there are studies that measure the benefits of dung beetles, but not in monetary terms. And the last gap is cost-benefit analysis, followed from a non-market valuation, has not been applied in this context before. So many of the non-market valuation, they quantify ecosystem services, but they're not used in a cost-benefit analysis, which would help assist future policy. And this project will be doing that. So there are four main aims. So the main aim here is what is the monetary evaluation of dung beetle to the Australian livestock industry. Second and third, they come along together. So what are farmers' willingness to pay for ecosystem services provided by different species of dung beetles, and what factors influence farmers' choice? So I want to have a dollar value for the different dung beetle attributes. So for example, some species, they are active in summer, other in spring. So would farmers, for example, be willing to pay to have a spring active beetle to control fly at that time? So this would be the type of questions that I will be addressing. This project will be national, and I'm hoping to get answers for various regions of Australia. My last aim here, to identify what the costs and benefits of the reintroduction of dung beetles to Australia. So now going through the papers. So paper 1 will be a GIS-based model. So I'll be focused on livestock productivity. So we know that we have evidence that dung beetles assist nutrient cycle, they can increase organic matter in the soils, control fly and gastrointestinal parasites. So if that's the case, this could have a potential to increase cattle weight gain and productivity as well. So what this part of the research will be doing is basically measuring the effectiveness of the dung beetle introduction program based on direct outcomes. So I'll be looking, in this case, my outcome will be productivity. So I'm hoping to get data from meat, wool, and milk. And I have a challenge here in how to measure this productivity and have like a standard form, so outcome per hectare. Yeah, but hopefully I can get, and most of this data will come from the Australian Bureau of Statistics. The specific aim here is to have a special monetary valuation based on direct use value of livestock products. And also I'll be questioning, does livestock productivity increase when exotic dung beetles are present and established in the area? If so, what species have a higher potential to increase productivity? So for these, it's likely I'll be using the difference in difference model, similar to the approach adopted by Card and Kruger in '94. So I'm sure many of you know, but I'll just go over the paper quickly. So they were basically looking the effects of increasing the minimum wage and how that affect unemployment. So what they did is they did a survey with fast food employees a couple of months before, a couple of months after the minimum wage was raised. And the survey was delivered to employees in Eastern Pennsylvania and New Jersey. So they chose those areas because they are likely to have similar economies. So I think Eastern Pennsylvania was the control and New Jersey was the treatment group, the group that had the increase in the minimum wage. So for my case, the difference in difference will then include the data before and after the introduction for the treatment and control areas. And the model just quickly has the assumption of the parallel trend. So we are assuming that for control and treatment area here, the productivity would likely increase anyway before the introduction. And that increase in the different areas, they would follow the same rate. And then after the introduction, then the difference can be attributed to the intervention effect. So for this reason, I'll collect data from 1960s, prior to the first introduction, to the present time, if I can get the data. And the main contribution here will be a visual map of the impacts of dung beetles on livestock productivity in various regions of Australia. Now going to the second paper. The second paper will be a non-market valuation with a farmer's perspective. So the first one was direct benefits, so things that are sold in the market, milk, meat, wool, and this one will be complementary, will be a non-market valuation. So I'll be collecting data through discrete choice experiments, and the survey will be delivered online to farmers. I'll be using an industry database. I think it will be a challenge to deliver this nationally, but hopefully I can get a high response rate. And so this is just an example of the attributes I might consider. So maybe fly control for diseases, active time, because dung beetles, they actually provide public and private goods. So the public would be fly control, but here I'll be looking at with a farmer's perspective. So in this case, it will be private benefits. And it's likely I'll be using random parameter logic models and mixed logic models. The specific aims, what farmers' willingness to pay for benefits provided by dung beetles, so have a dollar value for that. What are the main attributes that farmers value when investing on dung beetles? And what are the main behavioral, economic, and demographic drivers of farmers' choice? Because some of the farmers would have a passive adoption, for example. They would wait the other farmer to get dung beetles and see from their experiences. Others would get their own dung beetles. So these are the things I'll be addressing in the survey. And the main contribution here will be a better understanding on the dung beetles attributes most valued by Australian farmers. And finally, the last paper will be a benefit cost analysis. So I'll be using the data from the productivity study and from the non-market valuation to assess the benefits. And I'll be looking with versus without the dung beetles introduction and see if the total benefits, they are higher than the total costs. The costs here, I will be assessing with the collaborators, and we will include things like research, costs with importation and monitoring. And I'll also do a sensitivity analysis to account for uncertainty. And the specific aim here will be understand the economic impacts of dung beetles introduction to Australia. And I hope this can assist with future resource allocation and policy decision making. So just a summary, this project will be basically measuring the impacts of exotic dung beetles on productivity, livestock productivity, as well as quantifying dung beetle attributes valued by livestock farmers in monetary terms, and discussing future policy decisions. I would like to thank you, our collaborators, Meat and Livestock Australia, the Australian government, CSIRO, the School of Agriculture and Environment, and the School of Biological Science. Thank you very much for listening. If you have any suggestions, any comments, I would be very happy to hear. Thank you.
Thank you very much for Marcela for a very interesting presentation. And now it is time for questions.
Oh, thank you for that good presentation. I just want you to go back to your objective number 2, because I did not understand what will be your unit of analysis. Where you have the difference in difference method, we're using the difference in difference method. So what is the unit of analysis here?
Sorry?
what is your unit of analysis? I'm asking this because I think you said you'll be collecting data from the 1960s to the present. So I wasn't sure then what is your unit of analysis, because you know, things might have changed a lot from the 1960 to the present. So if you're trying to do the difference in difference, then I wanted just to understand what is the unit of analysis that you are able to track, you know, that difference between those two time periods. Yeah.
Okay, so I think I'll be looking at by species. So I'll be looking, for example, if the dung beetles were released in the 70s. So if they were released in the 70s, I'll probably do 10 years before, and 10 years later, I'll be looking at data on productivity. And to define,
can you unpack a little bit what do you mean by productivity?
Yes, so that is a challenge. So basically, I'm waiting for data from the Australian Bureau of Statistics, but I'm hoping to get data on production of wool, milk, and meat, cattle and sheep. And hopefully I can get these outcomes and put in different areas. So I'll be looking at statistical areas. So I'll have the map of Australia, and I will try to define my control and treatment area based on the dung beetles distribution. So I'll probably be doing a species distribution model to know where they're present, where they're not, and take areas that are similar in climate, for example, and areas that had the dung beetle, that has the dung beetle now, and areas that don't have the dung beetles now. And then I will compare those areas. That will be my treatment and control. I don't know if it's clear.
Right.
Yeah, I can see where you're going, but I think in terms of the method then you are trying to use, I'm not sure how you're going to do that with the difference in difference methods, because I think the assumption is that you need to know what is your unit of analysis. That's why I was asking, what is your unit of analysis? Is it regions? Is it, what are you capturing here? Yes, Ben.
Yeah, sorry, just a comment. So the ag census was collected in every year when you go back to the 1960s. So we got a big job in getting the ag census at the smallest statistical area. That's actually it's basically a shire, or it's now called a statistical area 2. So we're trying to rely on the fact that Australia did a massive experiment with dung beetles. They released them in some areas, not in others, and you find some statistical areas which have dung beetles and others that don't. So we're relying on being able to compare livestock stocking rates, productivity as a measure of productivity, and things like milk yields. But it would be good to come and talk to you about how we measure productivity from the data available. So to answer your question, we're using the statistical area 2, or whatever was the smallest geographical unit that they measured at a particular time, and then we're using as the productivity measures output of beef, output of wool, and we're probably going to have to try and aggregate those in some way. So it'd be good to talk to you about that.
I think Ben, what I'm asking is that what is the sample size? Even if you are talking about these areas, for you to put up this statistical model, what is the sample size? How many areas do you have? That's my main question. For the study to be valid, how many areas do you have, so that you are comparing within these two time periods, and you're looking at productivity as your outcome of interest? Do you have that? Yeah.
We would probably have in any, this is quite a challenge, but we should have about 40 statistical areas with and without. I suppose we'll have to look. I mean, I would imagine that the original stuff on difference in difference had quite large sample sizes, but we're going to have probably probably 30 to 40 with and without dung beetles at a particular time.
Okay, that's just my main concern, the sample size for it to be, to make statistical sense, yeah.
That's a good question.
Yeah, thank you, Ami.
Abby, you have a question?
Yeah, sure. So I just wanted some clarification around the attributes that you flagged for the choice experiment. So, and sorry if I've understood these, but one of them was around fly control. So that's in relation to preventing disease for livestock.
Yeah, that's right.
The other, you mentioned active time. So is that related to the seasonality of when the dung beetles are active?
Yeah, that's right, yeah.
Because I'm just wondering about, really, that's not really the outcome that the farmer cares about. That's sort of something that the dung beetles are doing that generates an outcome. And I'm just wondering what is the outcome you're trying to measure through using that as an attribute? And is that not related to disease control in terms of times of the year when flies are more prevalent, or so what's the purpose of that attribute?
Yeah, so basically that was just an example, because I'll actually be running focus groups with the farmers to define better the attributes. But yeah, so I'll be looking, I'll just go back to this slide. Yeah, so I'll be just trying to get a perspective, so this can help with potentially future imports, like imports of new species.
I guess the question is whether a choice experiment is the right approach, because obviously what you're measuring in a choice experiment are discrete attributes that are not causally related to each other. So it might just be worth having a think through what you expect you might find in those focus groups from the farmers, and whether all of the things that they care about are actually leading to the same outcome, in which case you might think about maybe a contingent valuation question or something a little bit different.
Okay, yeah, that's really good. Thank you, Abby.
Thank you, Abby. Ram, you have a question? Ram?
Thank you, Asla. I think part of my question has already been answered by Ben, but I'm thinking about the D&D, the difference in difference. The control and experiment areas, whether it is a statistical area 2 or whatever, is the dung beetle spreading over time and your control areas are shrinking? I don't know. I might suspect, is that the case or not? Just to think about. And second question was also partly alluded by Abby. I was just wondering, you are interested in indirect use values in your second objective. So the method you are using might give you multiple type of values. So how do you precisely frame your question to measure the indirect use values? I don't know the answer, but I just have a question. Thank you.
Yeah, thank you very much.
Michael, you want to raise your question?
Everybody's piling in on exactly the same issue. Merit's just put a comment in. I think it's just the question about that when you with your DCE, you're saying it's to get the indirect values, but potentially you're going to get the direct values as well. They're going to express their values for the productivity outcomes as well. Yep. So I think that is just a matter of digging that out as to what actually you're picking up. It may not be a bad thing to actually say you're going to pick up both values in two different ways. You can actually try to measure it and then ask them directly, and then ask them how much they value it using the valuations approach. But I think, yeah, just need questions to think a bit about what you're getting out of the valuation approach.
So, yeah, could I just make a comment? It's
yes.
Yeah, thanks guys for the feedback, guys. We we have put a little bit of thought into the different attributes and how they might relate to each other, but certainly yes, we'll need to explore some of the other options. I think there are some distinct outcomes that are different from each other with the dung beetle activity, and there's also some other attributes around risk, like risk of establishment. But thanks for the feedback, and so looking forward to sort of mapping out all the different outcomes that beetles provide and what would then be the best, making sure that discrete choice experiments are the best way to address the question.
Cheryl, you want to raise your question? Thank you, Fiona.
Sorry, I'll just clarify here. Just so what you are saying is, like I said, I was be doing indirect use value, but actually potentially the farmers will be looking this as a direct use value because they'll be looking at productivity, which is a direct use value. Is that what you mean? Yeah.
Yes, the answers they give may reflect a whole bundle of values, not just the whole thing, rather than just them being able to separate out to say, I've got my productivity, my milk gain, which I'm going to ignore, and now I'm just going to tell you about this other little bit over here. They may just be giving you the whole thing, all those values in one hit.
Yeah. Okay.
So, yeah, but without seeing what the attributes are or how you frame it, it's difficult to know, but you may just be able to have a really neat experiment design that can unpack all that.
Yeah, cool. Thank you.
There is, just as I can't answer Michael's questions or Abby's questions because I have, you know, failings with choice experiments, but interesting thing is that dung beetles are actually they're sold, you know, so $5,000 a box in New Zealand. So we might be able to use that as possibly a way of getting the value of a marginal species. Well, an additional species to either introduce dung beetles to a farm or add an additional dung beetle species to a farm.
And they're not available here? There's no market emerged for them here?
Oh yeah, there's a market. I think Jacob, who co-supervises, says he doesn't want to get into the complexity.
Yeah, there's a market for them.
Yeah, there's a market for them. You can buy them. You can either wait and hope your neighbours adopt, or so that's where we get the time choice. You can wait for the duck to fly or walk to your property, or you can actively engage in buying them and hope they establish, because there's no guarantee.
So the obvious question is, how much is that of that activity is going on, and is that a line of research in the thesis to actually look at that in that market?
I don't know whether there would be my feeling is that there isn't. Well, I don't know. Yeah, potentially. I don't. It's in my mind, it's a little bit out of what the scope, but potentially could look at that. Just with the so I think just to provide maybe a little bit more explanation around the dung beetles. Like Marcela mentioned about there being different species of dung beetles, and I guess with like the choice experiment, we wanted to look at with the winter active versus summer active issue, like some of the outcomes that different species provide, whether it's nutrient cycling, whether that's, you know, more important for farmers in winter or more important over summer. Like those were sort of some of the the values that we wanted to try and get at, so that we can provide advice to the people that are importing, you know, different species about what are the traits that are most of value.
I just have a follow-up question, which I think it might be relevant when you look at the difference. The question is between the time periods, let's say the 70s and the 60s and up to now, what variables will you be collecting to control for the change in quality? Because if you think about productivity, then what you may be capturing may just be productivity, maybe from genetic gains or from any other source other than just the beetles. So if you just assume the difference that you're going to see is because of that, given that time period, I think it might not be quite correct. So you may have to think of how to control for all the other factors that may be affecting productivity.
Yeah.
Yeah.
Yeah, that's really good.
Yeah.
Thank you.
Okay, thank you very much. We have to stop our presentation now. So I thank both of the speakers. You did a very good job.